Here is the technical definition of standard deviation. Suppose we have a set of n different pieces of data. We have data point 1, data 2, data 3, up to data sub n, d sub 1, d sub 2, up to d sub n. This is all of our information. And the mean is some x bar. Then the standard deviation is this. Crazy formula, but look at it briefly. d1 minus x bar is how far d1 is from x bar. How far is the first piece of data away from the mean? How much does it deviate? Then we square that. We take the how far is the second piece of data away? Because remember, you do everything in parentheses first. How far is this second piece of data away from the mean? How much does it deviate? Square all the deviations, then you add them all up, and you divide by n, and then take the square root of the whole thing. But you only use that formula if it's a full set of data. If it's a sample, we use the almost exact same formula, but with an n minus 1 divide by n minus 1. Sometimes this is called sigma sub n and sigma sub n minus 1 to indicate whether you divided by n or you divided by n minus 1. Let's do a quick example. It's not that easy to work with. I'm going to roll some dice and get, let's say, 5 numbers. Let's say our data is a 5 on 2 dice, and a 6 on 2 dice, and a 4 on 2 dice, and an 8 on 2 dice, and a 3 on 2 dice. Okay, so the question is, how spread apart are these numbers? I look at these and I think, we didn't get anything above 8. That's kind of unusual. These are fairly close together. What is the mean? Well, we have 5 pieces of data. So n is 5. The mean is 5 plus 6 plus 4 plus 8 plus 3, all divided by 5, which is 11, 15, 23, 26 over 5, which is 5.2. That is our x bar. Our standard deviation, sigma, this is a full set of data, so we're going to use n. Sigma sub n is, oh golly, how much does the first piece of data deviate from 5.2? It is 5 minus 5.2, which is basically 0.2. Well, it's negative 0.2, but when you square it, it becomes positive 0.2. And we add to that 6 minus 5.2 squared plus 4 minus 5.2 squared plus 8 minus 5.2 squared plus 3 minus 5.2 squared. We add all of those up. We divide by 5, and then we take the square root. What is that? 0.2 squared plus 0.8 squared, well, minus 0.2. It doesn't matter because when you square things, they all become positive. Plus another 0.8 squared. Yeah, that one's 0.8 up and that one's 0.8 down. Plus, what is that? Not 3, but 2.8 squared plus, and this is 2.2 squared. How can some of them be 0.2 and some be 0.8? No, that is 2.8 away. We could just crunch this out on the calculator, but the cool thing is just about any calculator that has the trig functions that is what is required for this course has what's called statistical analysis. Watch this. View, I don't want standard scientific, I want a statistics calculator. Ta-da! Now, I want to put in the data, and I'm going to put in the data with either an add or a sigma plus button, some sort of plus button. First piece of data is 5. Add. There's that data. And then 6. That's a piece of data. And then 4. Add that piece of data. And 8. Add that piece of data. And 3. Add that piece of data. On a fancier scientific, big graphing calculator, you might have to go into modes. It might be confusing, but you should learn how to do this. Because watch this. We say x bar, bang. There's the 5.2. Sigma sub n right there, 1.72. So, if we crunched all of that out, we would get 1.72. 1.72. And what does this say? This says that most of the data is within the mean x bar plus or minus sigma. That is 5.2 plus or minus, let's call it 1.7. 5.2 minus 1.7, I don't trust myself right now. Go back to the regular calculator. 5.2 minus 1.7 is 3.5. And I can do the other one in my head. That is 3.5 to 6.9. Well, how many of these are in that range? 3.5 to 6.9. This one is in that range. This one is in that range. This one is in that range. That one isn't. And that one isn't. So it's close to 2/3. This is what standard deviation says. It says, what do you have to go plus or minus to get most of the data in your set? From the mean plus or minus. So when someone says, well, you know, my dog weighs 80 pounds, you say, is that normal? What is the average weight of that type of dog? And how much does it vary by? And this sort of question we will get into in the last video in a bit more detail.